Hi everyone. So today we'll deal with a question from limiting reactant. Of course, under limiting reactant, you need to know how to get the number of moles available and the number of moles that will be needed. The advantage of this question, you notice that we've been given a lot of number of moles already, meaning that those are the moles that are available. So for you to calculate the number of moles needed, you need to be using what we call mole ratio. So we'll start with this question. We can solve it in this same video. Then we'll go to this question. We'll also solve it in this same video. Even the third one, we can solve it in this same video. Then we'll proceed to the remaining two in the next tutorial video. Let's try to dive in these first three questions. We see how we're going to deal with them. All right, we proceed. So the first question, they're saying how many moles of carbon monoxide are needed to produce that, meaning that we need to come up with a mole ratio between this mole and the one which is here for iron. How do you write a mole ratio? It has to be 3 to 2. You just get the moles that are there, which were used to balance up the equation. So we have the number of moles already given for iron, which is 35. But we don't know what number of moles is here, so we'll do this. Then you'll be required to multiply this and that. That will be 2x equal to 3 multiplied by 35. When you divide by 2, you find that the number of moles that will be needed for iron has to be as follows. So that will be 3 multiplied by 35. Then I'll divide this answer by that. So we are getting 52.5. 52.5 moles is the number of moles that is needed for iron itself. That is according to the first question. Then the second question, they're asking us how many. Of course, this has to be many. How many moles of iron ore will be required to react with 4.5 moles of carbon dioxide. So they're talking about this and that. Even here, we'll be required to use what we call a mole ratio. How do you use mole ratio? This one is having 1 mole of it in this entire reaction, so we'll just say 1 to the number of moles for that one. So in this case, we have 1, 2, 3. So we've been given one of these moles already, which is 4.5 here. Then there I put your x. Okay. So if you multiply this and that, you get 3x equal to this and that, it will be 4.5. When you happen to divide, the value of x will automatically be 4.5 divided by 3, which is 1.5. 1.5 moles. Very simple and straightforward questions. No need of struggling with them. Okay. We try to go to the other question whereby they're saying how many. Of course, this has to be men, not men. How many grams of iron ore will be produced? All right, so in this part, they're asking us to calculate the number of mass, or what mass is it going to be required for us to produce this amount of moles for iron. So what you do, you also be required to come up with a mole ratio between this and that, then find the number of moles first of all for the one which is here. When you get the number of moles, you can change that same number of moles to a mass using the formula for moles. So this one is having 1 mole in this reaction. There we have 2, so we write 1, 2, 2. Then what do we have on this part? We don't know what this is. And how many moles do we have there? Is 0.570. So when you multiply this and that, you end up having 2x then this and that, it will be 0.570 over 2 over 2. Then x has to give us something. So we have 0.570, divide this by 2. We are getting 0.285 moles. So we can change this number of moles into mass. How do you change? We need to know what is the molar mass for ion O. So the molar mass for this one will be as follows: 2 multiplied by 5.85 plus 3 multiplied by 16. Okay, so that would be 2 multiplied by 5.85 plus of course 3 multiplied by that, it has to give us something like 48. So we're getting 159.7 as the molar mass, 159.7 grams per mole. So we can change this number of moles to mass. How do you change here? So it's something which is very simple, because we know that mass is equal to number of moles multiplied by molar mass. So just multiply moles, which is 0.285 by 159.7. Perfect. So the number which is here, I'll just say multiply this by 0.285, and I'm getting 45.515. 45.515 grams. That is the mass which was produced for ion ore after the reaction. Let's try to dive in the remaining 2 questions in the next tutorial video. Try to subscribe. Try to also like and share this video for it to reach a number of people. Thank you.